All right, so I've got an equation over here, guys. Oh, I wonder is still factorizing. I wonder, we are like done with factorization. Everybody who's been with us at Watobe since the beginning is like a factorizing buff now. They know how to factorize everything. They even know about like algebraic fractions. That's how great they are. That's how awesome they are. Okay, I'm going to ask a really dumb question, guys. Okay, I'm going to ask a dumb question. Just indulge me for a second. If I said to you guys that 10 is equal to 10, do you guys agree with me? I'm sorry, Awande. I know Awande has been with us for a while. Do you guys agree with me? Yes or no? 10 is equal to 10. Yes? Ketiwe says yes. Samuel says yes. Mirula's like, ma'am, what are you getting at? Like, what nonsense is this? What tomfoolery is this? How can you ask such a question? Yes, the answer is yes, because we understand that 10 is equal to 10. But the second I start unbalancing things, once I start doing this, 10 plus 2, is 10 plus 2 equal to 10? No, Courtney, absolutely not. Absolutely not. So if I want something to be equal on both sides of an equation, if I want my left-hand side to be exactly equal to my right-hand side, I need to be able to make sure that I'm doing the same thing on the left that I am on the right. So if I add 2 on the left, I must also add 2 on the right. Okay, Kara was like, big no. Yeah, it's a big no. Okay, so I need to keep balancing this equation. Whatever I do on the left, I have to make sure I do on the right as well. Okay, now, when we are looking at this particular question that I've got over here, when we're trying to solve for 3x minus 4, and Braden has already jumped the gun and gone all the way to the end of the question. Okay, what I want to do in order to get this answer is I want to do reverse operations. No worries, non-policy. Okay, I want to do reverse operations. That's what I want to do. So I want to do some mathematical manipulation, as Funzo put it in the other class. We're going to manipulate this equivalency in a way that x ends up sitting on its own. So the first thing I'm going to do, guys, is I'm going to add 4 on this side, because I know that -4 plus 4 will give me 0. But just like we said with 10 plus 2, if I add 4 on this side, okay, I also need to add 4 on the other side. Good, so I'm going to add 4. Okay, Samuel, not exactly, not 100%. Okay, it's not exactly substitution. Substitution is when they tell you if x is equal to some, and then you have to take x and put it into the sum. What we're doing is finding what x is. We are solving for x. Okay, so now I've added 4 on both sides. I need to make sure that my sum is equal. Okay, I need to make sure that my sum is equal. So -4 plus 4 is 0, but on this side, I've got 11 plus 4. Now what I've got on this side is 3x is equal to 11 plus 4, which is 15. Now, guys, if I had to ask you, over here, I've got 3 multiplied by x. If I want to get rid of that 3, which is multiplied there, how then do I get rid of it? If it's multiplied, if I needed to do the reverse operation, what would I do? I would divide. That's it, Momo. Excellent. I would divide. I'm going to divide by 3. And again, what I do on the left-hand side, I need to do on the right-hand side. Divide by 3. Okay, good. We're dividing. And then we're going to learn something very important today, guys. When we get to the very end of a sum, when we get to the end, we need to say, therefore, x is equal to 15 divided by 3, which is 5. Okay, now you can't just say x is equal to 5 or 5. Karabo, I see you. You've just put 5 in the chat. Okay. You've just put 5 in the chat. We don't allow that. I need you guys to write the answer that I want in the chat is, therefore, X is equal to something. No worries, Tumelo, welcome. Good, but I want the therefore, Karabo. I want these 3 dots. Therefore, it shows me that you've come to the end of your answer. That's it, Amy. That's exactly what I was looking for. Therefore, X is equal to 5. The therefore is therefore the answer. So you must use the therefore for the answer. Okay. Make sure. All right. Okay, let's do a bit of recap of grade 9 maths. All right, Alicia, this is my favorite part as well. Teacher Nelly will tell you as well. She loves the section of algebra. This is her favorite section. Yes, she does. All right, I'm going to give everybody.
It's easy and it's very like procedural. You have to do it a way that you were taught. There's nothing different.
Exactly, I agree. I'm going to give everybody 5 minutes to answer questions 1 to 4. And when you're done, I want you guys to put the fire emoji in the chat for me. Okay. Braden, and I unfortunately cannot do that. You know what I'm going to do, Braden? I'm going to use question 1 to explain to you what we did in the other question, okay? Because everybody, I'm going to have to pull everybody else back, and that's not going to be fair. So just hold on for me, and then we're going to do the exact same thing we did up top with numbers 1 and 2 and 3 and 4, okay? Yo, Kioratile is just like on fire. Kioratile is already done. Sure.
That was fast.
That's it, Alicia. That's it.
That's the spirit. I'm gonna get everything right.
Mirula's done as well. Patrick just sends a smiley face. Winnie, I know, we probably know many different methods. I promise we all do. We all do. Okay, and I'll show you.
There are many ways to kill a cat.
There are many ways to skin a cat. Yes, teacher Delisa, that's it. Felix got it. That's it, guys. Thanks, Lina Mandla. And Mbuso's done, and Jabulo's done, Azifari's done, Tatum is done, Emelda's done, Mirula, Kioratile, and me, I'm also done. I also put the fire emoji, guys. I'm also done. Everything, all of them. It wasn't hard at all, Samuel. It's not. It's grade 9 work. We know how to do it. We know how to do it. Wigulo, do you have a question? Oh no, there goes the hand down. Awesome. Omolemo and Chloe are with us as well. And Tanyani. All right, I think that's enough people for us to get started on the answers. All right, so remember, guys, we can do this many different ways. I know a lot of you guys have been taught to take things over the equal sign, right? So if I had to take negative 18 over the equal sign, it would become plus 18. A lot of you guys have been taught to do this, right? So if you've been taught to do that, you're not wrong at all. Ketiwe is still on number 4. Keep going, Ketiwe, keep going. All right. So what we can do is we can either take negative 18 over the equal sign and make it positive 18, or we can add 18 on this side, and what we do to the left-hand side, we need to do to the right-hand side as well. So negative 18 plus 18 will give me 0, and I will end up with 2x is equal to 12 plus 18, which is 30. And then I will divide by 2 on this side and divide by 2 on that side. And then I better not forget my magic words. Therefore, x is equal to 50. And for those of you like Tatum who are just giving me answers like x is equal to, you're wrong. You forgot the therefore. Okay, Braden says, where did you get the 2 from? Braden, there's a 2 in front of x over here. Okay, so it's 2x. Samtana's like, where did you get the, do you have to add the therefore? Yes, yes, it's necessary, guys. It's very necessary. Okay, so here's what happens, guys, most of the time when you guys are writing. You're writing very long sums. When we get to things like complex procedure sums, you're going to be doing more than one thing at a time. Okay, more than one thing at a time. So we need to make sure that we know where your sum ends. And the therefore tells us where your sum ends. And Patrick, 30 is the same here. It's 12 plus 18. I added 12 plus 18 and it gave me 30. Okay, I hope that makes sense. Okay, yo, everybody in the chat, like you guys are just so, just excellent people, excellent. Let's talk about number 2, right? I know I want x on its own. This is my goal is to have, therefore, x is equal to something at the end. So I've got positive 7 over here. So I'm going to minus 7 and minus 7 on both sides. Well done, Inganati. Okay. Oh, Mirula even found the therefore sign. She made her own therefore sign. Excellent. Right. So 7 minus 7 is going to give me 0. And I'm going to end up with negative x is equal to, and then I have to do this operation. 3 minus 7, that's going to give me negative 4. Okay. But I don't want negative x. I want x. So I still need to divide by negative 1. And I divide by negative 1. Okay. Somebody says, ma'am, do you minus the number by itself? Yes. Yes. So if the number is 7, if I want to get rid of it, I minus by 7. If my number is negative 8, I plus by it so that I can get 0. Do you see how my answer is always 0? So I always know, I always make sure that I'm doing the opposite so that I can get 0. Okay. Let me see. I know the answer to question 2. However, I'm not exactly sure how I got there. All right. It needs to look something like how I'm doing it now. Okay. Oh, well done, Mirula. A colon and a stop sign. Well done. All right. Therefore, x is equal to 4 because negative 4 divided by negative 1 will give me positive 4. All right. Well done, guys. What's up, my sweetie?
No, ma'am, I just found the answer. I'm fine now.
Okay, excellent. All right. Okay, Amahelang's like, how? Amahelang, you need to be a little bit more specific. How what? How what? Let's be very specific there. All right, let's look at this next one over here. Remember, guys, again, I am isolating x. I want x on its own. So I'm going to move everything else to the other side. Okay. Okay, for those of you who are still a little bit confused, Alicia's already given us the answer. Good. If you're still a little confused, guys, the method that we're using here, okay, the method that we're using here is going to be the same for every single sum that we are doing. The things that we are doing are not going to change. We're going to keep doing them. Okay. All right. Amohelang says, how did the answer become +4? Remember, Amohelang, we had a negative and a negative. And a negative divided by a negative will give us positive 4. And that's how we get positive 4 over here. Okay. Thank you, Teacher Nels. All right. So the first thing I'm going to do on this side, guys, is I'm going to take my negative 5 over to the other side. I'm going to +5 and +5 on both sides. Negative 5 plus 5 will give me 0. So I'm going to have negative 4x is equal to, and then I have to do this part over here. Negative 13 plus 5, and I have a feeling Amy minus 5 on the other side instead of plusing 5, because I should have gotten negative 8 instead of negative 18. Negative 13 plus 5 will give me negative 8. Okay, and then I want to get rid of that negative 4, so I'm going to divide both sides by negative 4 by negative 4. Okay, therefore, that's it. Therefore, x is equal to negative 8 divided by negative 4 is going to give me positive 2. And you guys are whole geniuses. Whole geniuses. Patrick, you can't just write 2. I want my therefore, and I want my x, and I want my equal to. You must make sure you write everything. Okay. Excellent. All right, let's look at number 4. You guys can pop your answer for number 4 in the chat as we go. Well done, Buntu. That's it, Murula. All right, guys, remember, at the end, now we're using y. So I know I'm going to do some stuff, a lot of stuff, and then therefore, at the end, I must get therefore y is equal to something. Okay, that's what we're looking for. So everything that has a y is going to go to the left-hand side, and everything that doesn't have a y needs to go to the other side. Okay, so I'm going to start with 4y. So I'm going to take 4y and I'm going to minus 4y so that I can get 0 on this side. Cancel, cancel. So I'm going to minus 4y on this side as well. And then I've got negative 3 on this side, and I want it to be on the other side. So I'm going to plus 3 on this side and plus 3 on that side. What I'm going to get is 7y minus 4y. 7y minus 4y is going to give me 3y. And then on this side, I'm going to have 6 plus 3 is equal to 9. All right. Now I know I want just y, so I'm going to divide by 3 on both sides, divide by 3 on both sides, cancel, cancel. Therefore, y is equal to 3. 9 divided by 3 will give me 3. Those of you who are just writing x is equal to 3, y is equal to 3, where's my therefore? Inganati, where's my therefore? Where's my y is equal to? You must give me all of it, all of it. Thank you, Gift. That's what I was looking for. Thank you, Wikuto. That's it. Hi, Zanuke.
Hi, ma'am.
Hello, my sweetie.
Ma'am, please ask, what if the 7y and the 4y, where the 4y is, I just took the 7y to that side. Is it fine, ma'am?
That's perfectly fine. You got to the same answer, yes?
Yes, ma'am.
Yeah, it's just that on the other side, you will have to divide by a negative on both sides, and you'll get to the exact same answer. No worries. Okay.
Okay,
It's just
thank
that
you, ma'am.
most people are used to seeing the x and the y on the left-hand side. If you can do it with the left x and the y on the right-hand side, that's fine. Okay.
Okay, thank you, ma'am.
Excellent. All right. Now let's look at these sums over here. Oh, I'm sorry, Akwando. I'm sorry, Akwando. Okay, let's look at this sum over here, guys. Now we know, let me move it over a little bit. I'm going to move all of them over, actually. Okay. What is the answer over here? I've got x divided by 3. This is grade 9 work. Yes, Chloe, it's grade 9 work. Okay. X divided by 3. If I'm going to do the inverse operation or the reverse operation of divide, I'm going to multiply by 3. I'm going to multiply by 3 on this side. Therefore, I must multiply by 3 on the right-hand side. Multiply by 3. 3 divided by 3 will give me 1, and I will have x left. I can go, therefore, x is equal to 2 times 3, 2 times 3, which is equal to 6. That's it, guys. Lusanda is cheating. Lusanda forgot the therefore and the x and the equal sign. Hi, Patu.
Hello, ma'am.
Hello, my sweetie.
Ma'am, can I answer number 6?
Yes, let's do number 6.
Okay, ma'am. So firstly, I started off by writing 2 over 3x divided by 2 over 3.
Oh, divided by 2 over 3. Good.
And is equals to 2 divided by 2 over 3.
2 over 3. Okay, excellent. Mhm.
Therefore, x is
Therefore,
equal
x
to
is
3.
equal to 3.
3.
Okay. How did you
Yes,
see,
ma'am.
if you're looking at these answers the way that they look, how did
Yes,
you
ma'am.
see that the answer was 3? Is it obvious at first glance?
No, ma'am.
No. I mean, I can see that these two will cancel for sure, right?
Yes,
But how
ma'am.
do we tell from this over here that my answer is 3?
Oh, the 2 and the 2 will
The
cancel.
2 and the 2 will cancel, right? But then it still
Uh-huh.
looks like the 3 is part of my denominator. Okay, actually, let's do something a little bit different. Okay, I want you
Okay.
to go with me here. Okay, trust me on this one. Right? Do you agree with me that this number over here is divided by 3? Yes?
Yes, ma'am.
So if I wanted to get rid of the divide by 3, what would I do?
Multiply it with 3.
Good, I would multiply by 3. And this 2 over here is multiplied to x, correct?
Yes, ma'am.
And if I wanted to get rid of that multiply, what would I do?
Divide.
I would divide by 2. Okay.
Mm-hmm.
Do you see how I'm multiplying 2 fractions by each other?
Yes, ma'am.
So what can I do in this case?
The 2 and the 2 will cancel, the 3 and the 3 will cancel.
That's it. I can cross cancel. Okay. So what I've
Yes.
actually done is I've multiplied by the inverse of this number. So I can multiply this side also by 3 over 2.
Oh.
And
Then
I've
the 2
got
and the 2 will cancel.
exactly x is equal to this 2 and this 2. So and what do I have left? Therefore, x is equal to
3.
3. Do you see how we get to the same answer? And you even see it in your answer as you put it down.
Yes, ma'am.
You see it. Excellent. All right. Tell me how would I do number 7?
Number 7,
Mhm.
ma'am, with the method that you just did, because I did it with my method.
Yes.
With the method that you just did, ma'am, we'd firstly take the 1 over to the 2, so it'd be plus 1. And
Good.
then we're gonna say 5 over 3 multiplied by 3 over 5.
Good. Yes. 5 over 3. So we're going to multiply the side by 5 over 3. Multiply the side by 5 over
5
3.
over 3.
That one
Yes,
and that
ma'am.
one will cancel. That one and that one will cancel. And I'll have, therefore, x is equal to the 3 and the 3 will
5.
cancel and we'll have left 5. I can bet you,
Yes, ma'am.
Patu, that my one is a little bit easier and nicer than yours, right?
Yes, ma'am, it is.
But you did that so beautifully. Very well done. Okay.
Thank you,
There are
ma'am.
many ways to skin a cat, as teacher Neliswa says. Okay. If your method works for you, keep going with that method. I like this one because it helps me skip many steps in between.
Yeah.
Okay.
Yes,
All
ma'am.
right. Excellent. Well done, Patu.
Thank you.
Awesome. All right. Let's look at number 8, guys. Let's look at number 8. What are we looking at number 8? What are we going to try and get rid of first? Vulenda, what do you think? You can type it in the chat if you want. What do you think we can do? Remember that this whole part over here, this whole top part is being divided by 2. What do you think that we could possibly do to get rid of that divide by 2, that ugly looking divide by 2? If we had to do the reverse operation of divide by 2. Atlehile's got the right idea. That's it.
All of them. I like the cross multiplication one. Just the fact that
Absolutely. We
we
can cross multiply.
Yeah.
Amy says take 2 to the other side. Keoratile says multiply by 2. That's it, guys. All of your methods, like 100%.
LCD. Yeah.
LCD, yes. Yo, yeah, I'm glad, guys, all that maths comes back to you. Yes, we can divide or multiply by 2. We can look for an LCD. In this case, because we only have a fraction on one side, we can just get rid of it by multiplying by it on both sides. So I'm going to multiply by 2 on this side. Okay, And then I'm also going to multiply by 2 on that side. 2 and 2 will cancel. And then what I'll have left is 3 minus 4x is equal to negative 3 times 2 is negative 6x. Okay. If this one works for you, it's so much easier because now I see things and then I can shift things around. Okay. So I know I want x on one side and I want the numbers on the one side, right? So what I can do is I can take the negative 6 over to the left-hand side. So I'm going to plus 6x plus 6x. And then I'm going to take the 3 over to the other side. And since it's positive over here, I'm going to minus 3 on that side and minus 3 on this side. The negative 6x and positive 6x will cancel. The 3 and the negative 3 will cancel. And what I will have left is negative 4 plus 6x will give me 2x, which is equal to, what I have left on this side is negative 3. That's it. We'll take the coefficients to one side, take the variables to the other side. All right. Now I have to get rid of that 2 in front of x, so I can divide by 2 on both sides. Divide by 2. Therefore, don't forget my therefore. Therefore, x is equal to negative 3 over 2. Belinda says, ma'am, can you restart number 7? Absolutely. All right, we can even take it one step at a time, guys. We can take it one step at a time. Let's do this. Let's go. We're going to get rid of the divide by 5 first. Let's first get rid of the divide by 5. So I'm going to go times by 5 on this side, right? Oh, I'm even lying. We need to get rid of that negative 1 first. Let's get rid of the negative 1. Be plus 1. Inganati says, I don't see 7. Inganati, try and zoom in or out. Okay. That will help, if that will help. Okay. And then if I add 1 on this side, I'm going to add 1 on this side. Okay. Negative 1 plus 1 will cancel. And I will have 3 over 5x is equal to 2 plus 1, which will give me 3. Okay. Excuse me. All right. Then I want to get rid of this divide by 5. I'm going to multiply by 5. And then I'm also going to multiply by 5 on this side. Okay. Cancel here and cancel there. So I'm going to end up with 3x is equal to 15. Tabo's saying, where did we to get the 1, ma'am? Okay, I'm not sure what's going on there. Please, can you rephrase your question for me, Tabo, and then we'll take it from there. All right, and then I'm going to get divide by 3 on this side, divide by 3 on that side. Yes, that is the easier way to do it, Atlerile. But mathematically, that's what we're doing. Okay. So 3 divided by 3 will give me 1. And then I'll have, therefore, x is equal to 15 divided by 3, which is 5. Okay. Did that make sense? I hope that made sense, Vulenda. Okay. Ketiwe, what's up, my sweetie?
Evening, ma'am.
Hello, my sweetie.
For number 8, I noticed that you didn't put the 2 over 1 for it to make sense more.
Oh,
Will we penalized if will we in the test or an exam will we be penalized if we don't put it over a 1?
Which 2, my sweetie?
For number 8, you said you multiplied to get rid of the denominator 2, you multiplied it by 2, but you didn't put the 2 over 1 as a fraction.
No, they won't. They won't.
Okay.
Or like this.
Yes.
No.
Okay.
Because anything divided by 1 is that thing. It's like me saying 4 divided by 1. 4 divided by 1 is still the same as 4.
Okay.
Doesn't make a difference.
Okay. Thank you.
All right, excellent. Bunolo, what's up? Hi, Bunolo. Okay, Bunolo isn't unmuting yet. All right, everybody's asking for us to do number 8 again. Okay, and yes, Teacher Nellis was right, guys. If you've missed something, we can always re-watch this video. Okay, we are recording it, so you are able to watch it again. All right, I want us to have a real look at the answer, at this over here, guys. What we have, remember in the questions above, let's look at this question that we had over here. This one, x over 3 is equal to 2, right? I had x over 3 is equal to 2. Do you guys remember that when we had x divided by 3, how did we get rid of this 3, guys? Tell me in the chat. How did we get rid of it? How did we get rid of the divide by 3? Tell me in the chat, guys. Bunolo, what's up?
Unmute. How to ma'am, we times by 3.
Good, we times by 3. Don't go away, Bunolo. Good, we
Yes,
times
ma'am.
by 3. So what we do on this side, we're also going to have to do on the other side.
I'm
Do
on
you
the
agree
other
with?
side. Yes, ma'am.
Good, and then these 3's will cancel and I'll have x left. Does that make sense to you?
Yes, ma'am. Ma'am, sorry for interrupting you. This is linear equation. This is linear equations, right, ma'am?
Yes, it is. Yes, it is. There's no x squareds or x cubed. It's linear.
Okay.
Okay, hold on. Don't go away. Don't go away. Now, remember what you just said to me over here. You said if I have x over 3 is equal to 2, I'm going to multiply by 3 to get rid of it, right? Now, over here, I have 3 minus 4x divided by 2. How do I get rid of that divide by 2?
You times by 2.
Good, I times by 2. And if I times by 2 on this side, what do I need to do on the right-hand side?
You also multiply by 2 because what you do on the other side, you do on the left side.
That's it. What I do on that side, I can do on this side as well. So these 2 will cancel just like they did in this example. And then what will I have left on my left-hand side?
Minus 6 minus 8x.
Not 6. Not 6. 3.
It's minus 3 minus 7x. Oh, don't we have 3? Oh, okay. Now I get it, ma'am. Sorry.
3 minus 4x is equal to, now on this side, we can multiply.
It's 3.
What's negative 3x times 2?
It's negative 6x.
That's it, negative 6x. Okay, does this look like a normal linear equation that you can solve?
Yes, ma'am.
And it becomes much easier, right? Excellent. Okay, then I'm sure you can solve it from here for me. Okay, I'm going to take the negative 6x over, which means that's plus 6x on this side. And then I can take the 3 over that side, so that becomes negative 3 on this side. Okay, so that's gone and that's gone. What I have left on this side is negative 4x plus 6x. I'm going to write it again on this side. I have negative 4x plus 6x, and that's equal to negative 3. I've shifted things around. Okay, now negative 4x plus 6x will give me 2x is equal to negative 3. And then to get rid of that 2 in front of x, I can divide by 2, divide by 2, divide. And therefore, x is equal to negative 3 over 2. And that's how we get to the answer. All right, I see many of you saying in the chat that I just cross multiplied, and that works perfectly. Because all I need to do is just put this whole thing over 1, because I can divide anything by 1. It doesn't make a difference. And then I can just cross multiply. Multiply this whole thing by 1 and multiply that by 1, or by 2, sorry. And multiply this side by 2. Okay, if you cross multiplied 100%, you did everything correct. Just like Teacher Nelisa says, there are many ways to skin a cat, guys. Okay. Yes, you can. Yes, you can write it as not just 1.5, negative 1.5. Okay. Samuel's like, I know this cross multiply as in Orlando Pirates. We don't speak of such people here. Okay. Yes, this is a recap, guys. This is a recap. Not okay, yes, it sounds bad. Maybe we should find a different thing, teacher Nelly. So maybe not skinning cats. We'll find something different.
It's very
Why would we
controversial.
skin a cat? Up here, I don't know. They just started calling it skinning a cat. So I'm not sure I know,
It's
guys.
just the same. Yeah.
All right,
My
guys.
teacher used to say that. That's what.
I'm sorry. Unfortunately, my own kids would kill me if I left. Thank you. I'm so glad. I'm so glad you're understanding. That's the best part. All right, let's take a bit of a brain break. Okay, park all that maths that we're doing. Skin a goat. Apiwe, what about
Yeah.
the poor goat?
But
What
some people
about
like
poor goat?
goats. So let's just forget about it. Let's not say it
Yeah.
anymore.
Okay, we're not skinning any animals. No animal skinning, guys. All right.
Yeah.
All right, everybody, you can put your pens and your papers down. Let's have a bit of a fun little game. All right, let's stretch a little, take a couple of deep breaths in, breathe in, everyone. And out. And in. And out. All right, okay. Now, this is a fun little game. It's called a magic square. For those of you that don't know, many ways to kill maths. Okay, yes, Alicia, I like that one. It looks like Sudoku Siamtanda. It kind of is, but not really. All right, so what I need from you guys with the magic square is I need you guys to add up all the numbers on each side so that they're equal to the same number on every side. So 12 plus something needs to give me 45. And 9 plus 15 plus something needs to give me 45. And this number plus this number plus this number needs to give me 45. But that one and that one and that one must also give me 45. This one and plus this one must also give me 45. And this one plus this one plus this one must also give me 45. I'm not done. That one and that one and that one going this way must also give me 45. And this one and this one and this one going this way must also add up to 45. Chloe, because I'm helping you with the answer. Technically, I'm not supposed to tell you how much it adds up to. You're just supposed to figure it out for yourself. Okay, I'm helping you. Okay, there's a pattern to this. Okay, Roma says 12 plus 9 plus 24, which is nice and easy. 12 plus 9 plus 24. What else? Nyeleti says 12, 27, and 6. Nyeleti, where do I put the 27 and the 6? 27 plus 15 plus 3, I see that one. All right, Patrick says 12, 15, and 18. Nice one. Nice one, Landile. 9, 15, and 21. Nice one. 6, 21, and 18. So we've got 6 over there at the corner. You guys are excellent at this. All right. I'm going to show you guys something very cool. Okay, I'm going to show you guys something very cool. If I divide, that's it, Akwando, you've got it. If I divide all of these numbers by 3, I'm going to divide each one of these numbers by 3. Let's see what happens. 12 divided by 3 will give me 4. 9 divided by 3 will give me 3. 24 divided by 3 is 8. 3 divided by 3 is 1. 15 divided by 3 is 5. 27 divided by 3 is 9. 6 divided by 3 is 2. 21 divided by 3 is 7. 18 divided by 3 is 6. Do you guys see how I've used all the numbers 1 to 9, but I've used each of them only once? Do you guys see that? I've used 1, 2, 3, 4, 5, 6, 7, 8, 9. And if I add all of those up, if I add all of them up, if I go 4 plus 3 plus 8, that gives me 15. And 9 plus 5 plus 1 gives me 15. And 2 plus 7 plus 6 gives me 15. And 8 plus 1 plus 6 gives me 15. And 3 plus 5 plus 7 gives me 15. And 4 plus 9 plus 2, 15. Okay, great. And Kioratile has already ruined the next one for everyone because she put the answer in the chat. Don't look at the chat, guys. Don't look at the chat. Don't look at the chat. All right. Try and figure out this next one. I'm not going to tell you how much it adds up to. I want you guys to tell me how much it needs to add up to on each side. Now, look at all the numbers, guys. Look at the kind of numbers they've given us on the right-hand side. Okay, Teacher Neliswa, I need to show you the coolest thing ever, that my grade 8s figured out today at Maths Elective.
What's that?
Okay, they figured out that in the middle, the number in the middle is always a multiple of 5. That's the first thing they figured out.
Oh, yeah.
Then they figured out that the numbers in the diagonals and at top, bottom, and left, right of the middle always add up to 10. So 4 plus 6 is 10, and 8 plus 2 is 10, and 1 plus 9 is 10, and 3 plus 7 is 10. I was so impressed. I mean, and the boy who figured this out, he's only 12 years old and he's sitting in a grade 8 class. Guys, he is just.
Because I didn't see it. I didn't see the trend. I didn't see it.
I know, see, Amtanda, even me, I
That's
was like, can I marry your brain? So cool. So cool.
Oh.
I know, Patu, it's amazing. Hi, Roma.
Hi, ma'am.
Hello, sweetie.
So I think I figured the second one out.
Okay. Are you going to give us the numbers we need?
Yes, ma'am.
Awesome. All right. Where am I putting what?
So for the third row, you're going to put 44 plus 99 plus 22, which gives you 165. And then you're going to put 22 plus 77 plus 66, which also gives you 165.
That's it.
And then you're going to put you're going to put 88 plus 11 plus 66. And then you're going to also put 88 plus 33 plus
That's
44.
it. Good.
And then for the last one,
in the middle?
55.
That's it. Oh, well done, Roma. That's amazing.
Well done.
Oh, well done. Yo, guys, this
55 is a multiple of 5. Wow.
All of them are multiples of 11. You see that? 88, 11, 22, 66, 44, 99. I think this is just the coolest thing I've seen in a while.
Yeah.
Patrick's like, I know you knew it. I knew you knew. Hi, Kitty.
Hi, ma'am. So I noticed something about this magic square, whatever. And I see that they all, like, it's all 1, 2, 3, 4, 5, 6, 7, 8, 9. But like,
that's it.
It's like double, it's like whatever, it's double numbers. Do you know what I'm trying to say?
Yes, I am. Because look at over here. All these numbers are multiples of 11. So what I can do is I can divide by 11. 11 divided by 11 is 1. 66 divided by 11 is 6. 77 divided by 11 is 7. 2, 9, 4, 3, 8, 5. I have used 1, 2, 3, 4, 5, 6, 7, 8, 9 once. I've only used each of them once. Okay, and that's the beauty of the magic square. We do get ones that are a little bit harder, but for now, we're going to be looking at addition. When I feel like you guys are ready, I'm going to complicate your lives a little bit more. All right, I'm going to do a quick intro to what we're going to be doing on Wednesday, because we were just practicing linear equations that we already knew. Kioratile, I'll make sure of it. Because
she's ready for a challenge.
Kioratile's like, next week, can we get a much more difficult one? Because you said that. Because you said that, I'm gonna get a nice and difficult one. All right, let's do one more sum. Now we're gonna do linear inequalities, guys. It's not me, it's Georatile. It's not me, Mirula. I can't help it. All right, what we're going to do here, guys, is we're going to be solving for a linear equality, but we're going to solve for it the exact same way that we would solve for a linear equation. There is no difference, guys. The only difference is the type of answer we get. Okay, if I said to you guys that x is greater than 2. I know I've written it in the wrong order. I should probably write it the other way around, actually. That's such a wrong order. If x is greater than 2, okay, Braden, that open mouth means greater than or lesser than. Okay. If x is greater than 2, guys, what is my answer for x? If x needs to be a number greater than 2, give me an answer in the chat. What number does that need to be? Anam says 3. Okay, so we can make it 3. Good. 3. Or, you're right, or higher. That's it, Nico. Yo, Nico, that was profound. Any number that's bigger than 2, or 4, or 5, or 7, or 20, or 56. All of these numbers are bigger than 2. X can be any number. Now, the difference between this and an equation, that's it, Inganati. 10, however much I want that amount in my bank account. That looks like a nice number. Okay. X can be more than one number. Okay, when we talk about inequalities, we're not just talking about one number. When we talk about x is equal to something, when I say x is equal to 2, x can only be equal to 2. But if I say that x is greater than 2, then, or less than 2 in this case, if x is greater than 2, I'm talking about many, many, many numbers. We can't talk about just one number. Okay, and that's the only difference between linear equations and linear equalities. That's it. Okay, that's all. That's the difference. Now, what we're going to be doing here, and the reason I chose this question is because I want us to practice substitution. Not substitution, distribution, not substitution, distribution. Now, remember when we were learning distribution, guys, this 5 on the outside, we multiply into the bracket, top multiplied by top. 5 times x will give me 5x. 5 times -1 will give me -5 is greater than. Tell me in the chat, guys, what is 7 times x? Tell me in the chat. That's it, Hasna. Brackets stand for multiply. That's it, Lusanda. Well done. 7 times x is 7x. Good. And then I want 7 times -1. Well done, Witepo. That's it. -7. Now, the rules are not going to change, guys. Remember when we were doing equations, we said that we want everything with an x on the left-hand side. And we want everything with a number on the right-hand side. We're going to do the exact same thing. I'm going to take 7x over to that side, and it's going to become -7x. And then I'm going to take this -5 over here, and I'm going to take it over to the other side and +5. So on this side, I'm going to have 5x minus 7x is greater than -7 plus 5. I almost forgot what I was saying there. +5. There we go. Those are going to cancel out. Now, tell me in the chat, guys, what is 5x minus 7x? Let me know. That's it. Many of you are forgetting the important part of that. Thank you, Imelda. Yay. Thank you, Imelda. Thank you, Samuel. Thank you, Limnandi. -2x. Thank you, Wikuko and Njabulo and Leon. Excellent. -2x. Well done, Winnie. -2x. Guys, don't forget the x. It's very important. This is greater than Negative 7 plus 5. What is negative 7 plus 5, guys? Negative 2. Thank you, Landile. I see your answer. It's negative 2. Okay. And now we end up with negative 2x is greater than negative 2. I'm going to do something really funky. And I want you guys to stay with me here. I'm going to divide both sides by negative 2, right? And Anam, remember, it's no longer an equal sign. There's no equal sign. That's a greater than or equal to sign. Okay. So these two are going to cancel. And the negative will cancel, and I'll get a 1 on the side. But what I'm going to write is I'm going to write x is smaller than 1. What did I do to the sign, guys? What did I do to the sign here in the middle? What did I do to the sign? What happened to the sign, guys? Have a look at this sign over here. Good, I flipped it. I changed it. I flipped it around, right? And I'm going to explain why we do that. Okay, the rule here says, remember this rule because it's going to come up again. The rule, okay. Write it down. If you're taking notes, write it down. If I multiply or divide by a negative, I flip my sign. I flip my sign. Write it down, guys. It's very important. If I multiply or divide by a negative, I flip my sign. And I'm going to explain why. Okay. If I said to you guys that 5 is greater than 2. Is that true? Yes or no? 5 is greater than 2. Yes, it's true. 5 is greater than 2. Now, I'm just going to be nasty, and I'm going to multiply the side by negative 1, and I'm going to multiply the side by negative 1. Guys, tell me in the chat, what is negative 1 times 5? What's negative 1 times 5? That's it, Mirula. It's negative 5. And then what's 2 times negative 1? 2 times negative 1 is negative 2. Okay. Now look at my sign in the middle. Is this statement still true? Is the statement true? Is negative 5 bigger than negative 2? No, Ketiwa, you're 100% correct. Negative 2 is bigger. That's why I flip my sign. I flip it. I must flip it. Okay, and that's why I flip it. Because as soon as I multiply or I divide by a negative, the truth of the sign in the middle becomes false. So I must flip the sign in order to make the equivalence or the inequality correct. Do you guys get that? Give me a thumbs up if you see it. Thumbs up. Excellent, Anam. Awesome, guys.